So today we have two objectives. One is to write an equation knowing slope and a point on the line and understanding point-slope form. So I'm going to teach you a new form. And I wanted to share with you how you could get some extra practice from the online book. This is out of lesson 6.7. And there are 4 personal math trainers throughout that lesson. So I kind of gave you a description which each of those personal math trainers would give you. The personal math trainer on page 201 is going to give you how to write your equation in slope-intercept form given a slope and the y-intercept. Now you've already done that on prior homework, but if you needed to practice that, that would be a good spot. And then the personal math trainer on page 202 is writing an equation given or with a table of values. So you're given a table of values and your job is to how to figure out how to write an equation from that. We're going to focus in on that in our notes today. And then the personal math trainer on page 204, given a graph, write its equation. Now I'm actually not going to teach this to you because I want to see if you guys can take what we're doing and go backwards with it. In other words, what we're doing is coming up with the equation and we could draw its graph. Can you look at the graph and figure out how to write the equation? Okay? After talking today, hopefully. And then anytime they put a personal math trainer on the independent practice, I haven't looked thoroughly myself, but I have a feeling it's more of a combination of all those things. It's more of a review. Okay? What I need you guys to help me do is to figure out what it is that we need in order to write linear equation or linear function. So I put a slash because there is a slight difference between the two, and we'll talk about that. We did talk about that a little bit yesterday. So what sorts of things will I see in an equation of a linear equation or a linear function? What types of things need to be present in that actual equation? Okay. Ben, what's one thing? They definitely need a slope. Oops. What else do we need to see in that equation? Now think back, we've talked about ways of writing equations. What are some things that maybe you have seen? Brian? We need a y-intercept. And I'm going to tell you that actually that's not we always have to have that. I'm going to show you today how even if I know a point, not necessarily the y-intercept, I can still write my equation. So 1 point on the line. Okay, what else needs to be in the equation? Now this may sound like, duh, she's really not looking for this, but you'd be surprised. Carly? Okay, that one I'm going to say is, yeah, we know that has to be there. So this is something a little bit more workday that we need that is got to be in our equation. Yes, the equation has to have an equal sign. Say something else, something else. Luke, you got something?
Numbers?
Well, the numbers are being represented by the y-intercept and by the slope, so we already kind of took care of that piece. Ben?
If you're doing a function of x, if you're doing an equation of y.
Okay, so we definitely need an f of x if it's a function, or a y if it's an equation. So we have a variable of some sort in there. Anything else, Matthew?
I was going to say a variable.
Okay, be specific. You already mentioned y.
X and y.
We need the x. So we need to have 2 variables, generally speaking, an x and a y, though you have seen equations that are written with only one variable, just an x or just a y. If it is asked to write a function, instead of writing y, you're going to write f of x. We do need a slope. Without a slope, we can't write anything. And we do need some other number. That number may be given to us as a y-intercept. Most likely, and especially tonight, you're going to be given a point. So I'm going to share with you how we're going to figure that out. But we're going to use a couple of old friends to help us do that. All right, so first thing I'm going to do is tell you that I've got a linear function, and I'm going to give you 3 points off of that linear function. So I know it's a linear function, so guess what that means I get when I graph it? What am I going to get? Oh, I'm hardly hearing anything here. Say it real loud. You're going to get a line, right? So that's going to come into play in just a second. So our table, because it says it is a linear function, we're going to write f of x, but we could write y. And for our purposes right now, in your textbook, when you're working on your homework, it's just going to talk about linear equations. So your equations will be written with y's instead of f of x. But understand, those are completely interchangeable, okay? So I've got 3 ordered pairs that I know are on this line. -1, 5, 3, -3, and 7, -11. Oh, that's a terrible 7. Okay. So let's see if anybody could get this one. This is kind of a tough question. It's hard to figure out how to say it properly without just giving it away. All right, you guys told me to write a linear equation or linear function. I need to know slope. I need to know a y-intercept or point on the line. I need to have a y or an f of x in it, and I need to have an x. In that chart, I see 3 points. So I got that piece covered. What don't I see? Carly? There's no slope. Can I figure out slope? Okay. Ben? You,
Yes.
okay. And what have we learned that would help me figure out slope if I'm given 3 points? No, rise over run means I have to graph it and count. We talked about page 321, a way to do this without having to graph and count, which obviously it looks like we need to remember and memorize. Kendall?
Isn't it like where you put the group with them, and then it's like one's over the other, like one ordered pair's over the other, and then you subtract or something like.
All right, you've given a very vague description of what it is I was hoping you would come up with. We actually need to be specific about what it is. It's an actual formula. Matthew N?
y2 minus y1 over x2 minus x1.
Okay, hold on. So what we're talking about now is called slope formula. And you said, tell me again.
y2 minus y1 over x2 minus x1.
Okay, and I'm going to say something's missing from this formula. Okay, Veronica?
And equals.
Yeah, it's an equation. So we got to make sure that there's an equal sign and something on both sides. So we have m, which we know stands for slope, equals. Now, a couple things to remember. These guys come from the same ordered pair. We put the y on top always, x on the bottom. These two come from the same ordered pair. If we mix them up, we'll get the wrong sign on our slope every single time. Now, what I want to do is figure out the slope of the points. But I've got 3 points. So I'm going to have to do this 3 times. So we'll start with the first one. Slope equals 5 over -1, -3 over 3, and then I'm going to connect and subtract. And what I notice on the top is I had a double negative, and that double negative becomes one big positive, and then I solve. And I get 5 plus 3 is 8, -1 take away 3 is -4, 8 divided by -4 is -2. Okay. So let's try slope, but from 2 other points. Let's try points 2 and 3. So slope, -3 over 3, -11 over 7. We're going to connect and subtract. Again, we had a double sign, so we're going to get a plus there in the numerator, and then we'll continue on with the math. So -3 plus 11 is 8. 3 take away 7 is -4. 8 divided by -4 is -2. Huh. Is that surprising? Is it surprising they would have the same slope? Okay. If they didn't have the same slope, look at what would happen. Here's the first one. Here's the second one. Is that a line? No, we got a little tent going on there. That's not going to work. Okay? So let's just verify that I'm on the right track here. Let's try the third one. Kendall, I'll get to your question in just a sec, because you're about ready to steal my thunder, I can tell. So we have 5 over -1. We have -11 over 7. We're going to connect and subtract. what I notice is a double sign, so I'm going to make a big positive out of that. And I get, oops, let's see, 5 plus 11 is 16. Negative 1 take away 7 is negative 8, which gives me a negative 2. So if you are told these points form a linear function, do you need to do slope 3 times to verify you figured out the slope? No. If it tells you you have a linear function or a linear equation and these are points that are on the line, you know that the slope for all the points will be exactly the same. Otherwise, you won't get a line. You'll get some sort of crooked looking thing. Okay? So, how many times do I figure out slope? Once. Once and only once. Okay? We don't need to do it more than that. All right. Well, great. So now I have one piece of what I need to write my equation. And now what I need to do is to get these other pieces. So I can easily get an x and a y because I just have to plug them in, right? And I have a point. In fact, I have 3 points to choose from. Which point do you guys want to work with on this one? Because they did not give us the y-intercept, so we're stuck with a point. Which one? First, second, or third? Third. Okay, I heard it first, so that's the one we're going with. So what we're going to do is take our information. We've got a slope that is equal to negative 2, and we're choosing to use the third point, which is 7, negative 11. Oops. All right, so here's what's kind of strange. I don't have the y-intercept, so I can't just plug stuff into the slope-intercept form like we've done in the past. I really don't know any other form. Standard form I do know, but I can't just plug numbers in and get standard form. So what I'm going to do is go back to what we just worked with. Let's go back to that slope formula. And what we're going to do is take this information and plug it in. So reminding you, slope formula looks like this. M equals y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. So we're going to use that. Now, we're going to have to alter it a little bit. Because remember you guys told me that our equation has to have a plain old x and a plain old y. So what I'm going to opt to do is in the front with a x sub 2 and y sub 2, I'm going to replace y sub 2 with y and x sub 2 with x. And then I'm going to put my point in with the x sub 1, y sub 1. Okay, so this guy is going to go there. So here we go. We now have negative 2 equals y minus the y value, negative 11, over x minus the x value, 7. Okay. Now, notice I've got a double negative on top, so it just becomes one big positive. All right. Now, the only form that we're used to writing stuff in is slope-intercept form. So remind me what slope-intercept form looks like. Ooh, that's an ugly color. In general, how do I write slope-intercept form? Oh, Stephen, thank you for joining the party. And what else? Okay, the generic form means I don't have numbers, I just have variables. So what represents slope? What represents slope? In general. In slope-intercept form, we have a variable. There we go. Then comes, after the m, slope-intercept form has specific things I have to write. That's what I'm asking for, is how do you write just the general slope-intercept form? No numbers have been plugged into it yet. Y equals m. What comes next? Nope, we don't add x to it. Justin?
Isn't it y equals mx plus b?
That's what I'm looking for. Slope-intercept form, m is the slope, b is the y-intercept. Okay, so I know my goal is to get to that guy. Right now, I got a y on the wrong side. So I'm going to use my symmetric property, and I'm going to rewrite the left side on the right, or the right side on the left side, and the left side on the right side. Okay, at least now I've got y in the right location. But the problem comes in that that's all I should have on the left side is a y. And I've got a y and an x. So what can I do next to get this equation on the left in black to look like the blue equation in the upper right? Don't be shy, McKenna.
You multiply x minus 7 times.
Okay, so we're going to go ahead and take that denominator, x minus 7, and we're going to multiply both sides by it, which allows us to get rid of it from the denominator. So now I've got y plus 11 equals, and this is vitally important, 2 times the quantity x minus 7. All right, it still doesn't look like y equals mx plus b. What next? What can I do now? Miss Sarah. Yes, what can I do now?
Subtract 11 from both sides.
No, I don't want to do that. Not yet. What am I going to do before I do that?
You're going to distribute the negative 2.
Got to get rid of those parentheses. So yes, distribution is the best first choice to do at this juncture. Okay. Otherwise, I can't subtract the 11 from anything because there's nothing to subtract it from. It's held up. So we're going to go ahead and distribute negative 2 times x, and we get negative 2x, and then we're going to have negative 2 times negative 7, which is going to give me a positive 14. Sarah, again, what do I do now?
Subtract the 11.
Now is when I get to subtract that 11, okay? And I get y equals negative 2x plus 3. Okay. That took a lot of work. And what's interesting is that you guys actually, in this work, we came up with a new form. That new form goes with this one right here. What does the negative 2 stand for? Slope. What do the 7 and the 11 stand for? Not y-intercept. Ben?
Points on a line.
Yeah, the points that were on the line. Remember, those are coordinates. So this is actually called point slope form. Okay. Now, just to give you a little background, this is the most important form that the high school said, you got to teach this form. This is so important because we're going to use this one on, and it's very, very, I think when they do Algebra 2, when they're doing their calculus, it shows up. It's a very important form. Interestingly enough, in the New Common Core book, it doesn't even appear. So I'm kind of confused what that means. I find it very useful. Okay? So in general, what does point slope form look like? Well, we have a y minus a y coordinate, y sub 1. That equals a slope times the quantity x minus an x coordinate. So again, m is slope, and the x sub 1, y sub 1 is a point on the line. Let me just kind of compare those two for a moment and show where people get into a little bit of confusion. So here's our generic y minus y sub 1 equals m times the quantity x minus x sub 1. And then here comes the one we had in the middle of our equation. Y plus 11 equals negative 2 times the quantity x minus 7. And if you recall, that's the ordered pair we used. 7, negative 11. So what is the difference between the generic form and our specific one? What do you see that doesn't seem to match up? Macy?
Instead of like subtracting y sub 1, it's adding 11.
Okay, so that's where it looks a little strange. Here the signs match, right? With x minus x sub 1, we have x minus 7. But over here with the y's, we have a minus in the form, but we have a plus in our equation. So here's what you do. It's really simple. Just take each portion that includes the variable, set it equal to 0, And now you know the original sign that was attached to that coordinate. And that says your point should have been 7, negative 11, which is what we started with. Okay, so that's where sometimes kids get confused, is because they see pluses, but the formula has minuses. And that's because your individual value has a negative sign attached to it. So if you're confused what your number should be, you can pull it out. Because I'll tell you, this is what I've seen on the high school final in the past. They'll give you this equation, the y plus 11 equals negative 2 times the quantity x minus 7. And they'll say, what's a point on the line? And you're supposed to say 7, negative 11. Without calculation, because all you have to do is look at it and remember the sign for my individual coordinates is opposite to what it looks like in the formula. This looks like a negative 7, but it's actually a positive 7. That looks like a positive 11, but it's actually a negative 11. Okay? Now, tonight you're not going to have to deal with that, but I'm just telling you, you can go both directions with this thing. Luke?
Is it always reversed on the symbol? Like for the orange, like it says negative 7 and then the actual thing would be 7?
Because the formula has negatives in it, what comes after that is going to be the sign that attaches. So if the sign is different from negative, then that tells you your actual number had to have a negative, so 2 negatives would make a positive. But again, if you remember this piece down here, sorry, my question is, what would I do to these equations to first write them in standard form? So what would I do to get y equals negative 2x plus 3 into standard form? So now you have to remember what standard form looks like. Macy?
You have to get x on the same side as y.
Got to get x on the same side as y. So how do I do that, Macy? What math?
You could add 2x.
I'm going to add 2x to both sides. Now, a couple other things that we need to know about standard form. No fractions are allowed. Lucky for us, there weren't any. We want to write the x in front of the y, which we did. And it's customary to let x be positive. There we are, standard form. Okay? So that took a little bit of calculation to get it that way. Dane?
Where did you get the 7 and negative 11
From our chart. Remember?
Oh.
From our chart here. This is one of the 3 ordered pairs, and you guys said third one, and that's the one I chose to use.
So, what would it be called then? Just the third ordered pair?
Well, it's just, we call it x sub 1, y sub 1. It's a point on the line. Okay? So it's just playing that role for us. All right? And it didn't matter what point I put in, I would get exactly the same equation out. Okay? And I could do that, but that'd be boring to have me resolve this problem multiple ways. Now let me ask one more thing. What if instead of writing the equation in slope-intercept form, they said write the function in slope-intercept form? How would the answer change if they said you now have what we call a linear function? Not a linear equation, but a linear function. How would that answer change? It's going to be a little minor change, not a major one. Dane, you got that one?
Would the y turn into f of x?
Exactly. That's the only change. Everything else remains exactly the same. Okay? So a lot of what we're talking about today is there's just multiple ways to write the same thing, and there's multiple ways to get to the right answer. Your job is to figure out which way you want to do. Okay?